Well, friends of mathematics, we're at it again, and we're talking about section 2.5, and we're going to deal with some inverses today. And I think the first thing we're going to start out with is, do all functions have inverses? And so what I'm going to start out with is maybe we'll have a graph here, and let's go through the point 3, 2, and how about it looks like that. Let's call this f of x. And as of right now, I have y as a function of x. And an inverse function, I'm going to say, may I express x as a function of y. And that's the mystery. And so we'll write that f inverse of y. And this is going to equal x. Now the dream here is I'm going to be using which of these two numbers in the inverse function? And the answer is we're going to be using that y value 2. And so we'll do f inverse of 2, and that definitely gives us 3. And it turns out for any given y value on this graph, there's only one x associated with it. And so yes, this function has an inverse. What about this one? What about this one? Let's use that same point 3, 2, and now let's do something like this, and let's call this g of x. Right now, certainly, y is a function of x. For every single x value, there is only one y value associated with it. But does g inverse exist? And the question is, if I say g inverse of 2, mind you, that is a y value. That's an output. And so we can see that when I use 2, there are different x values. I'm going to certainly get 3, and then I'm going to get this other point as well. And so g inverse is not a function. And so we'll say that g inverse does not exist. Now, we will talk later in the semester how to make partial inverses. Say if I only considered that first half, it would be invertible, or this half, it would be invertible. But as of right now, if our function passes the horizontal line test, meaning that if a horizontal line crosses only one time, we have an invertible function. Well, friends, let's go into an applied function now, and let C equal f of t be the cost of producing t items, and suppose f is invertible. And what I like to do here is I will make a little picture. I'm going to have t values over here, and I'm just going to write that these are items, and my function f takes things from the domain, which are some number of items, and it gives me some c value, which is cost. And so because we know that f is an invertible function, what I can do is I can think about this having the inverse, and I'm going to write that. Now, this should be very clear as far as what type of variable and what type of thing goes inside the inverse function. If I was going to say, certainly, f of 3 is equal to 7, well, we knew that that 3 would be equal to some number of items because it's going into the parent function, and that 7 would be some value of cost. Similarly, If I had the cost of 7 and we wanted to take that back to 3, we could express that as f inverse of 7 equals 3. In general, for this problem, f inverse takes in a c value and it gives to us a t value, and that is the takeaway. Now, I know that there's a lot of algebraic textbooks out there that like putting x inside there, and that's trash. We can't do it. The inverse is taking something from the range and bringing it back to the domain, and more often than not, the domain and the range do not have the same unit or meaning. I think, the main reason that we have these inverses, other than to bring us from the range back to the domain, is I can get rid of a parent function. If I do something like this, f of f inverse of c. Well, what this does is this starts me out in c, and it brings me to a t value over here, and then you put that t value in, and you get c back out. And so in other words, when I compose a function with its inverse, we can say that murder occurs, and I'm only left with that argument. The same is true if I do it in the opposite direction. But let's think about this. If I gave you something like f inverse of f of 17, and the question is, this is by all means going to be equal to 17, but in the context of this problem, what's the unit going to be? Well, that 17 is some number of items because it's going into my parent function. And so the 17 items goes in, it gives us some cost. We don't know what that cost is. That cost is f of 17, and then we bring that back with the inverse function to 17, and the answer here is items. There's one last thing I want to do with us. Suppose c is equal to, 3t plus 12. Yeah? And now I'm just kind of spitballing here. And I could say also that, how about c is equal to f of t, and the function is equal to this. And if I was asked for a formula for f inverse of c, well, what am I going to do? Well, so I have c equals 3t plus 12, and f inverse of c is equal to t. So what we're going to do here is we're going to make sure that I'm using my output variable, and we are going to solve for t. So I can subtract 12, I can divide by 3, and this is my inverse function. This is f inverse of c. Frequently, you'll write just f inverse of c is equal to c minus 12 over 3. If you wanted to, you could split that up into 2 pieces, but it is no problem if you don't do that.